All right, so I'm going to talk a little bit about my process to do LRGB processing in PixInsight. And this is my process, not necessarily anybody else's. It's a process I use now. I'm sure in a year that my process will change just a little bit. And what I plan to do is to give you an overview of my processing and how LRGB fits into it. And then we're actually going to do a demo. So this is kind of my current processing, the big picture of my processing, given one-shot color, narrowband, and LRGB. And at this point, my goal is whenever I take these pictures, you're going to calibrate, register, stack, possibly using WBPP, and then cropping and then background extraction in all of this stuff. But my goal, at least in the top part of this, is to eventually get to a place where I have an RGB image, and a luminance image. And then, so all of these will go into there. Now, the LSC and a narrowband don't have luminance in them, so you have to extract the luminance after a color calibration. With LRGB, you do have luminance, so it comes directly out. Now, having said that, there are people that don't bother gathering luminance data and just have RGB filters that they use, and that basically then becomes the same process as narrowband, so that you come over here and then extract the luminance out. So you can do it that way. I really don't know if there's a disadvantage to not taking the luminance. The advantage to not taking the luminance is that for the given amount of time, you can gather more red, green, and blue data. So that's something to be aware of, that you don't necessarily have to capture this luminance data. You can extract it out. And if somebody will remind me when we get to the point where we have an RGB image, then I can show you how to extract that luminance out. After I have an RGB image and a luminance image, I go through these different processes on here. You have to do a background extraction just to get the colors balanced. And then there's a color calibration, a multi-scale linear transform, and then a histogram transformation. So you do histogram transformation in both of these, and then you combine the LRGB combination. My arrow is not working here. It should go all the way down to there. I've been working on this slide and changing it a little bit. The RGB goes through this. The luminance I will take through deconvolution, a multi-scale linear transform, and histogram transformation. I will not be doing any deconvolution tonight. That's a bigger subject and probably deserves its own session. I will take it down and combine it with LRGB, and I will probably not do an SCNR would remove a particular color. I've tried it on this image, and I try to take out the green is generally what I take out, but I think I'll leave it in. I like it better with that in there. The TGV denoise, TGV denoise is also a noise reduction tool that I've been using. It does quite a good job. I won't be going through that. After that, you have to do a histogram transformation to readjust the background. Then there's the local histogram equalization is a sharpening tool, and then another MLT that uses the details portion rather than the noise. So basically what I'm going to do is when I get down to the LRGB, I'm just going to go to curves to get a final image. After we get down to here, you'll know how I do the LRGB. So if I make a mistake, I'm sure somebody will correct me, but let's go to this, to PixInsight here. And you can see that I have all of my images. I've calibrated and stacked them, and done a DVE on them, and I'm ready to actually combine them. Now, to combine them, you really can't combine them. If I connect this up to here, lay it on top, you can see that the stars don't line up except in the upper right-hand corner. You kind of do. So we need to get them aligned first before we do anything else. And what we're going to do to do that is, can I get rid of this thing up here? Because I'm going to need to, I want to hide.
You should be able to pull it off to the side.
Can I? No, just that easy. All right, I'm trying to make it too hard. So I'm going to do a star alignment. And I will take as my primary image, my reference image, I'm going to take the luminance. You can use any of them. I'm just going to happen to use luminance. I'm going to add views, and I will add the red, the green, and the blue images. Load those in, and this will then align them. It'll take a few minutes. If anybody has any questions, feel free to chime in. All right. So if I stretch those, you can see that there are dark spots on the sides, and that double stretch that. So, and if I do this, you can see that they all line up. Now I try to keep my desktop organized, so you may think me a little bit OCD, and you're right, I am a little bit OCD, and you'll know it for sure once I do this, because I like to keep things looking the same in all areas. So what I do is, since this was my reference image, I just create a clone and just call it registry. And connect it to there. So what you do now, there's a couple choices. We obviously need to take care of these black areas, and you could do that right now with a dynamic crop, in which case you would be doing it to all four of these images. But instead of that, we're going to go to channel combination, which is only going to combine the red, green, and blue images. So if I can make sure I get the right ones, and you can assign these however you want. If you wanted to assign the red to green, and the blue to red, and the red to to something else, that's up to you.
Hey, Doug.
Yes, sir.
Why do you use channel combination and not LRGB channel combination?
Well, the simple answer is that's the way that I've listened to some experts through Masters of PixInsight. You've been to one of those sessions, and this is the way they do it. The other thing is that when I get to let me go back to here. Deconvolution is something you do on your luminance, not on your RGB image, because it affects your luminance. That's what you're trying to make. You're trying to make the stars a little bit smaller. So I have my luminance separate, and but I need to also get color calibration and multi-scale transform done on the RGB. So that's why I split them at this point, or handle them differently.
I get that part. I guess my real question is, what is the difference between combination and LRGB combination? Is there any difference?
Um,
Because
Yeah,
LRGB combination is pretty easy.
yeah, that's true. I mean, we can, because I got it up here someplace. We can not use the luminance and just use the red, green, blue. That's a good question. It's very possible that you could mess with the weights. Maybe there's more power here, but I couldn't answer that question as to what is different if you were to turn this off. Oops.
That's the way.
Off.
I mean, that's the
And
way
then
I
do
normally
those.
do it. I turn off the L and just do the RGB because I haven't learned how to do deconvolution yet, so I can't really push the luminance just yet.
Yeah.
So that's basically what I do, is the opposite of what you just did. I uncheck the luminance. I check the RGB.
To tell you the truth, I don't know. I don't know the difference, or whether there would be a difference. It could be that there's no difference. So anyway, let's go on. I'm going to click that and we get a new image. Close this.
Hey, Doug, I had a quick question. Sorry.
Sure.
I don't know if my volume was down earlier or maybe I missed it, but I was just wondering, so, I know the red, green, blue channels and, SHO, but the luminance, what did you describe that earlier? Like exactly, like, is that the overall brightness of all three ranges, or?
You got it. If you were to add up all of the red, green, and blue pixels, or all of the narrowband pixels at any one point, then you would get the luminance.
And why is that important in like taking it out? Is that so you only have those other colors left, or?
I don't understand the question. Repeat it.
Or I guess, didn't you say you subtract luminance at some point, or?
No, I extract.
Oh, extract. Okay.
So like if right here, if I click this, it will extract the luminance out from this particular image. So I can get the luminance that way, and it probably looks pretty close to that. And this was captured. This was what I captured when I was out in the field. And this is basically what they call a synthetic luminance.
Okay,
So
thank you.
Let me shade that one and get rid of the right ones. I'm going to change the name of this thing to RGB. And now we need to crop out all of these stacking artifacts. You can see a little bit of green actually over on the side where my images didn't line up properly, even on the RGB. But I need to crop this out along with cropping the luminance, so that when I get to the point of combining them, they will be the same, that I can stack them properly. To do that, use a process called dynamic crop, and define what you want to be cropped out of here. Now I go in and check the corners to make sure that I'm not sticking over into any black areas. I try to get as much area as I can. I know that I'm probably going to crop it later to a better size. So I try to keep as much area as I can. Now, before I actually execute that, take this little triangle and drop it there. That takes this definition, and it's inside of the dynamic crop, and it's inside of this process. I need that. I'm going to crop this. I need that so that these images will be this. If I take this definition then and drop it on here, it crops that, and now these images will still line up. But I was actually practicing this morning, and I cropped this one, and then started doing work, and then got to the point where I was going to combine the L and the RGB, and realized that I hadn't cropped this thing to the same definition. I'm sorry. Computer yelled at me. So we're done with the dynamic crop. And what we need to do now is to take out this. Our problem is that the colors aren't balanced. Now, there's a couple ways to take care of this. One is called linear balance. We're actually going to just use the background auto modelization. I'm going to do the automatic background modelization first. I'm not going to subtract anything because I'm just going to look at what it predicts to be the background. And if I make this big, you can see that, well, where there was nebula, where there's a galaxy, there's lots there. It's black down in this corner. I agreed that it's stretched, but it's just not smooth enough for me to subtract out any kind of background. So I don't use, on this particular picture, I don't use that. Instead, what I will do is to use a dynamic background. Actually, I'm going to close that because I have it up here. Let me reset that. I'm going to set my tolerance to 1 because I know I need to do that. My sample generation, I'm going to make big squares, and I'm going to use 6 going across. I'm going to generate. So if you make them big, then you don't need quite so many, and you can see that there's none down in here. We're going to take care of that. I'm going to move some of these away from the nebula so that I'm not using any nebula that, or so it won't confuse any nebula with gradient. I'm also going to add some, I usually add some in the corner here. No, DBE is another thing that could use some discussion, but I'm not going to worry about it. I'm going to add some lines in here that will go across and look at the values across this whole thing. Do a vertical line out of that one, and a vertical line out of that one. Let's do a horizontal line out of that one. Let's do a horizontal line out of this one. So now if I look at my background, that's going to extract, it is much smoother. Looks much better, except for the smudges on my screen. So now we're going to do an image correction. We're going to subtract, and we're just going to discard the background. So I can get rid of this. Yes. And it looks much better. And looks like I'm getting nice, good color in this image also. Next, I believe what's next, I got it over here, is a color calibration. I need a background. I learned this a couple weeks ago from Masters of PixInsight, but if you take this thing and drop it right there, then it pulls the name in rather than having to use this. And I restretch it. Sometimes the color changes. So now we need to, I believe, I'm in the right place. We've done background color calibration. We need to do a multi-scale transform. These are the values that I have to start with. Let me bring up the working preview. One of the things that I've added in the last 6 months is using a linear mask to mask out the stars so that I'm all in the bright areas. So I'm really only working on the dark areas. And let me show you what the preview mask looks like. Now, when you do this, you have to unstretch the image so that it looks like this. And now you can start to make changes. If I go to 70, I also want to make the edges a little bit fuzzier. Let me zero in here in this area. I'm going to raise this back up to 90, not 900, maybe. So it protects. So what we're doing is protecting these stars a little bit, especially the bigger stars. Like, you know, we got stars over here that need to be protected from the process that I'm about to do. And you can see it's fuzzy around here. That's the smoothness. If I make it this number bigger, then it eats into the darker areas. So these stars might even just disappear in this mask. So let's leave it at that. I'm going to turn the preview off. Go back to the big view. I'm going to turn the screen stretch back on. And let's go back in and look at things because we are already applying these values to the noise direction. If you go up here and you click this, it will click on and off the processing, and you can see that it's doing quite a bit. Now, what I'm looking for is stars, and if you look, you can see there's circles around these stars, these smaller stars, and it might do something to try to eliminate those, but I'm not going to worry about them right now. And on the big stars, you really don't see them. Well, maybe there's a little bit there, but I don't see it. And the other thing is that these stars are going to be so small. I mean, when you look at the big picture, unless you're going to pixel peep, you really can't see any effect of those.
Hey, Doug, can I ask a question?
Sure.
If you zoom in again to where you were a second ago, those black areas, the little spots that you have throughout there, I use MLT to kind of mitigate those. Is that the best process for doing that?
Well,
This isn't bad. I've seen a lot. I mean, I have a lot worse sometimes.
yeah, I know. So do I. In fact, if I take this out, you can see that it gets, you know,
Yeah, exactly. Yep.
And this mitigates it somewhat. But the other thing you need to remember is that we're looking at the RGB image. So if I was working on the luminance, I would be more concerned about that and trying to figure out how to take care of those. Because, you know, the pixels being dark, or this area being dark in here, let's zoom into that, you know, that 1 pixel right there, the brightness of that is not defined by the RGB, it's defined by the luminance.
How do you know that?
That's what luminance is how bright something is.
Right, something is. Because I find that most of the time I can remove like the dark areas in RGB, and then I use luminance and chrominance to smooth things out. But if you say that the other two are also usable to get rid of these black spots, I'll put more more effort into that.
Yeah, it's a black spot doesn't have any color. It's it's black, but its brightness is not defined by, well, it is defined by RGB, but because I'm going to be well, I can't do that. No, we got it pretty much defined. Because I have the luminance here, this will define more of how bright things are in my final picture.
Thank you.
Mhm. So I need to apply this. I don't think I applied it, did I? I need to read. Why did my color calibration go away? Anyway. All right. So I'm going to apply that multi-scale linear transform that we defined here. All right. So the next thing that we need to do is to do a histogram transformation. I'm going to click this check mark down here. We'll bring the histogram for this into here. I was always doing it through this, and then saw that you can actually hit this and it'll bring in this histogram into there, and it's all, of course, very, very dark. Let me bring that in. So this is my process. So this starts to get to the point where everybody's making their individual choices. And my process for this is I bring up the dark point to very, very close to there. I'm dropping some pixels, but that's probably okay. Let's brighten this up a little bit so I have a little bit more control. And I think that's okay. The other one then is what the background is, and this is where you get to artistic choices. Many people like the really dark background. I don't. In fact, if you hold down your right mouse button, you can see the values for this particular pixel come up, and you can see that the red is going from 0.0034 to 0.462. And the same thing is true for the green and blue. You can see what those values are changing to. So the ones on the right hand side, I want to have about 0.1. So to do that, you take the gray point and you just start bringing it down, and you keep testing it out. Going around looking at different samples as we go a little bit. I'm not.
So the main reason you use HT is to adjust your darkness, your background, essentially.
Well, I want to get rid of this this thing down here too. It's not doing me any good, so I may as well get rid of it.
Do you ever use any other channels in HT?
Excuse me?
Do you ever use any of the other channels besides RGB?
No.
Just
No.
RGB?
No, it's balanced. If I'm going to change the balance of the color, I'm going to do that in the curves transformation tool.
That's where I do it too.
So, and a lot of this is, I'm messing with the brightness, but again, this is an RGB image, and so the luminance is going to be more concerned. I'll be more concerned about this when I'm actually looking at the luminance image. So let's close that. Drop that there. I'm going to get rid of this preview. We don't need it anymore. I'm going to close this down. I can close this down too. So there's my RGB image. It is to the point where, I'm at this point. Actually, I'm down here, so I'm ready to take it down into the LRGB combination. So now I need to do basically the same stuff on the luminance image. Like I say, I'm not going to do any deconvolution tonight. Maybe I'll give I've gotten it to work. I got a process that works pretty well that I learned from Masters of PixInsight. So maybe I'll do something with that this coming winter when it's too cold to go outside. But so we're going to do an MLT on a transformation histogram. We're going to stretch the image. So MLT luminance, and these are the values that I start with. Let's bring up again. I'm going to look at the preview mask. I need to do that on an unstretched image. And I think this is probably just a little bit too much. I don't know what values we used this morning. You know, we're reducing noise with this, and you know, people will ask, well, what about the noise in these areas? Well, these areas are really bright, and so the signal to noise ratio isn't actually is pretty good. The dark areas, which is white in this case, those areas are the place that you really want to work on your noise, because your signal is so low, it'll have a larger effect there. Let's take the preview off and re-stretch it. And let's go down in and look at it. And again, I can see, I don't know if you can see it, but there are some circles in around some of these, around these stars, on the mid-sized stars. Let me go in and look at it in a little more detail. And I could choose to do something about that, but this is not a demonstration on MLT. But I'm looking at, if I turn off what this definition is, you can see all of those dark pixels show up. So it is certainly reducing noise. And the big stars don't have any artifacts around them. The little stars do, but the little stars are little stars. These would actually be a little bit smaller with a deconvolution. They'd be a little bit smaller and brighter if I did a deconvolution. Let's get back to the big image. I'm just going to say, sure, let's do that. That was quick. Not as many channels to do. Was it quick? No. I apparently did not drop something on properly. All right, what's going on? So we're back to the dynamic crop. This is what it should look like when I'm
You're
done.
not stretched.
I'm not stretched. Well, I applied it. So if I stretch it, I'm fine. Let me unstretch it, close this, and drop this on there. And it should be stretched down. Oh, I'm not stretched. You're right. My mistake. I'm a step ahead of myself.
This is
Thank
MLT.
you, Mark. This is MLT. My mistake. So we have it stretched. We don't have it stretched. We have the MLT done. Next, we do the histogram transformation. And this basically follows the same process as I did before, though I will be more concerned about the values in the back there, in the background, those values. So let me move these down in, stretch this. What do you think, Mark?
Well, I pull the black all the way up to the edge of the histogram.
Yeah, I know you do. I just don't like the way it looks.
Well, then you adjust the.
Sometimes I gotta adjust the other one down.
Yep.
But to a certain extent, it makes the galaxy so bright.
Anyway, this is luminance, so you want that bright. You'll adjust that later in curves.
Yeah. Or this is all data, right? I can redo this if I don't like it.
That's right. That's what the undo button is for.
Control Z.
Control Z. Yeah.
All right. Now let's drop it on there. I don't like the way this looks, but I'm going to go on faith that it'll turn out good. All right. So,
well, you can adjust it. You can adjust the histogram again in after you combine.
yes, I can. Actually, I usually wait until curves. And we're going to be jumping right to that once we do an LRGB combination. So yeah, now we have an RGB and we have a luminance. And we're down here at the LRGB combination. So we're going to combine those. The way you do that is to select the way I do that. Other people do it differently. Is to take that and just apply that luminance to here.
I do it that way. The way you just did it.
Yep. If I go in here, if you look at the bottom, you can see the values of my screen. You can see the values for the background.
Yeah, that luminance really helps it pop. That's nice.
So let's close that. And like I say, I'm going to ignore all of these other steps that I do down here, because this is basically, now you've got an image like you would with a one-shot color images that you would pre-processing. So let's just go ahead and play with curves just to see what we got. I usually like to bring up. I got some really nice data here. I was really happy with what I got. I got some weird purple stuff around there, but it just adds to it, I think. Oops, didn't want that one. I never like my curves to hit the rail up here, except at the very end. And you can also pull this one down. I don't know if you knew that or not. So lots of color in there. Again, it's just doing things to taste. Yeah, I don't want to do that. So I would, I might play with this a little bit more. Let's apply the saturation, even though I think it's probably just a little bit much. But one of the other things that I do is worry about the competition between the main object and the stars. If this is not a real big object or it's fairly dim, then the stars can kind of override or take your eye away from the thing that you wanted to look at. Andromeda, this galaxy is so bright that it draws your eye to begin with. But I could. I did this on some other ones, but let's just do a range selection, and I'm going to pull that all the way up. But I'm going to make a mask here so I can work on the background as opposed to the foreground. Close that just so we got that right. The other thing is that there's this. It's kind of it looks like misty or smoky or something, and I kind of like to limit that also. And to do that, this mask is probably just a little bit big. I'm going to apply this mask and minimize that. We're going to reverse. So now I'm working with this stuff, and I'm going to go back to curves. And if I wanted to take this background down, there's two ways to do it. Number one is to use the luminance so that you can deaden it down a little bit. Like I say, you don't want to deaden it down too much with this image because it gets too bright, and I think the galaxy gets too bright. The other way to do it would be to take the saturation so that the colors don't compete quite so much with the colors in the galaxy. That's the other way that I'll do it, to try to balance it out. But again, it's so bright, it's so big and bright that, let me take that off, that I don't think that I need to change these colors at all. That's a personal opinion. So that's basically what I was going to cover tonight. I don't know if there's any other questions.
That really looks nice, Doug.
Thank you.
Do you?
Yeah, I was going to say some of the detail there is amazing.
Do you have any recommendations for? So when I use masks on something like this, especially when it's a large object, that boundary area, if you apply the mask too roughly, it looks fake. I can't think of a better word. That boundary between the galaxy.
Right.
How do you deal with that with the mask?
The only thing you can really do is take this smoothness all the way up. Let me pull this get this back up. If I wanted to, I want to go the other direction. If I wanted to dim that area just around it, but you can see that it takes a while to get from all white to all black, and that's going to be controlled by this smoothness. I mean, that's pretty harsh. You're going to see that line if you use that. So I usually, when I'm going to do this particular task, I push this smoothness all the way up to 100. The fuzziness doesn't do quite as much. It actually changes it the other way. You can see the star center is there.
Do you find that you're typically putting the smoothness up that high for most objects, or just for certain ones?
For
for
nebulas, yeah. For nebulas, yeah. For galaxies and nebulas, yeah, I push it up this high just because I don't want to see that harsh transition that you're talking about. Let's take this, I need it up to be able to put on a mask. Let's reverse the mask. Pull this down here. Close that, bring up curves. And bring up luminance. So now I should be able to, this kind of messy, color area, I should be able to take care of a little bit by looking at where it is in the curve. So I want to lock the dark stuff down, and then I'm going to pull this down. But yeah, if you're talking about, that looks awful, right? So because you start to see the sharpness, so you really can't mess with it a whole lot. Let's pull this down a little bit.
Yeah, I find that I have to do the go through the mask parameters a few times before I get a boundary that's smooth enough.
Yeah, you can also, I've been playing with it here. I had these up way up too high.
Normally, I don't have my, I forget what that first field is called. You have it up in, I think, the 50s. Normally,
Oh, yeah.
I'm in the 26-ish range. And then my smoothness is about half of what I think you're up really high, right?
Yes, it's at 100. My smoothness is at 100.
Yeah, typically I'm under 50 on smoothness.
Yeah,
and
I
about
just,
26-ish on the other one.
for this particular task of trying to control this stuff down in here, let's just turn it off so you can see what I'm changing. I turned the smoothness way up, but that's only for this task if I'm going to do something like this. Because I
Yeah,
just want as gentle as I want as gentle transition as I can get, so that we don't get that harshness.
yeah. This is one of the harder things to learn how to do properly.
And we still got, there's that greenish area right there again. I saw on my mosaic that I've been putting together. Will, did you have a question?
I don't. Did you mention at the beginning though? If was this through the TAC or your 80 or?
This was through my stellar view, my 80 millimeter stellar view.
Okay, with your ZWO.
Yes.
Okay, cool. Yeah, no, nice work. Good job explaining.
Look, this is beautiful. Just briefly, for somebody who's not well versed in PixInsight, what sort of a machine are you using in terms of just general specs, processor, RAM, SSD, etc.?
I have an i7 running at 2.6 and 16 gigabytes installed. I think I can make that bigger if I need to. The drives, storage. This is an SSD. Where's the information on it? How do I get the information on it? Do I have to go into settings? Yeah, I think I have to go. Oops.
Doug, you've actually shown me what I need to know. You don't have anything that's ridiculously insane, so. And
No, but
it
they
doesn't seem like
say-
you're spending a lot of time waiting for the machine to process an image. Am I correct?
What's that?
Do you spend a lot of time waiting for your machine to process?
It depends upon the image, you know, and the process you're going to do. Like this TGV DN will take lots and lots of time, but I'm running 1,000 iterations at least to begin with. In fact, when I do this, and let's go ahead and do this, I actually make a let's go down into here, a preview, and I pull this preview off. I'm going to close this temporarily. For some reason, it wants to stretch that. But then what I'll do is to apply it to this small section. I had to pull it off because this will do the whole thing, the whole image, even though you had a preview up. And so it's done, and I can look at these. And what I do is I look at these iterations. And so I change this now from 1,000 to however many iterations it had. And I can get rid of this. Yes, I want to get rid of it. And apply it to this thing. And this will take a bit. And it'll do this 3 times. So it's got to go up to 100% 3 times. And you can see how long it takes. Now, in terms of the disk, I was going to look. Actually, I can look in here. You can see that it's really, really slowing me down. Properties. So, and actually, I'm actually, well, the memory swap is going to this SSD. The images that I've been working on are actually on my external drive, my passport. So this is an SSD. I don't know whether or not, General, does it have?
You go to, if you go to the tasks, what is it? Something called
Task Manager?
Yeah, and then you can see the performance of your disk.
Yeah, the other thing is that there's Wi-Fi stuff going on because I got 2 people. But here's
But if you click on your disk,
yeah. There's the SSD. So it's doing a lot of memory swapping with the SSD, which you want that to be fast. So here's actually my disk where my images are. It's my external disk, the E drive. But actually, there's the HDD. Why is this going so much to the C drive is my SSD. And I have a hard disk beside. But I know. If you want to make it real fast, then what you could do is to take your images like mine off of my USB drive and put them on my SSD and manipulate them there. But PixInsight spends a lot of memory, uses a lot of memory on your SSD or on your primary drive to do work.
so Ron, to answer your question, it's your processor first, and then memory. What I've learned is that the recent updates to PixInsight are allowing you to also use your video card. So some of these gaming machines that have powerful video cards in, it would actually take advantage of that and use some of that processing power also. So it's all in how deep is your pocketbook.
Okay, that's all very helpful. Really.
Hey, Doug,
Yes, sir.
are you looking to do future presentations to continue on this path? Like, I'm dying to learn about deconvolution, for example. I'm not.
Yeah, a lot of people are. Yes, I think that I'll probably do a deconvolution sometime before March, sometime before April.
Okay. Thank you.
Yeah, it's deconvolution is a confusing thing, and at least the process that I have now makes it much simpler. The real trick about any of these tools, I was just gonna, before I answer the question, I got the TGV denoise is done on it now, and you can see that it took my noise and reduced it quite a bit.
So why do you use TGV denoise when you can limit the noise in MLT?
You can use both. I use both. Some noise is easier to take care of once you're stretched, and TGV denoise is used on a stretched image.
Okay, thanks.
So now I put your question off, and I forgot what your question was, Suresh. What was it again?
My question was just about that. I'm not sure which question, the noise one or about doing deconvolution.
Oh, the deconvolution is confusing, and what you need to do is to on any of these tools for that matter is to know what to look for when you do something. You know, how do you know you've done too much or not done enough? So knowing the little knobs and stuff on the tools is one thing, and what they all do, but knowing when it's too little or too much is also important. So in my procedures, I've been adding in little things that say, okay, now that you've done that, look at this. And if it looks like this, you've done too much. If it doesn't do what you think it's supposed to do, then change things a little bit more. And in fact, I'll put in, change this a little bit more. With the deconvolution tool, what I will do is you end up playing the way that I do it. The only number that you end up playing with is this number here, this global dark. And what you do is you look at the stars, and if the stars get bigger, then you go one way. If the stars get smaller, that's what you want. If they get smaller too much, then you got to change this number again. So
do you have any, I don't know what you call it, a guide or notes on deconvolution that you could post somewhere maybe on how you do it?
I'd have to look. I have some notes on it. I'd have to look at them, and I probably would post them when I give my, again, this is my process of deconvolution. So maybe I could do that in November or December, since is there a lot of interest in the deconvolution?
I would say yes. I know for myself, that's my dead end right now.
How about anybody else?
I would say there's a lot of people that I talk to that are kind of in the same boat.
Anybody else on this?
No, I'm still, I got PixInsights, but I haven't used it as much as I'd like to. I'm still kind of easing with Deep Sky Stacker and Photoshop. So
okay.
Not at that point yet.
You need to learn how to use WBPP.
Weighted batch preprocessing?
Weighted batch preprocessing, yeah. Which is a script that's in batch preprocessing, weighted batch preprocessing. And once it comes up,
it kind of makes your own Deep Sky Stacker where you kind of automates what the stacking parameters kind of thing.
And processing. So
you add darks, flats, lights.
Yeah.
If you use WBPP, at least as a minimum, and use it, because I use it all the time. I don't do anything manually. I run everything through WBPP.
Right.
Even if you use
forget something or mess it up.
Even if you use it stock out of the box, and then you take those, you could take those, make TIFF files and take that into Photoshop. You'll find out that even the noise reduction that WBPP does will really help you even get a head start there. And then what you'll find out is that, well, I'm already here in PixInsight and we've already done things, so why not just stay here,
Okay, that does kind of make it simple. I see you at the bottom. You just, you add your biases, darks, flats. Okay.
Yeah, if you guys are using CMOS cameras, there's no reason anymore to use bias frames. There's been some studies done that say if you're using a CCD, yes. If you're using a CMOS, don't use bias anymore. Unless you're using a DSLR, then you should use bias.
I was just gonna say, yeah, okay, yeah.
That's the only place that I use the bias files is when I use my camera.
So do I.
That Nikon D750.
So what do you guys, instead of using bias with CMOS, do you just use your darks or dark flats, or what do you use instead?
Just use your darks.
Just use darks. I use, and then use dark flats with your flats.
Yeah.
Because your dark and your dark flat already has the bias in it. And if you're using WBPP, it compensates for that and does that math anyway. So it knows it's in there.
But the dark is your exposure time. Like in my case, I used 3-minute exposures. So your
Right.
darks are at 3 minutes, whereas my bias frames, I use a library bias file, and those are shot at, I think, whatever the maximum speed is. Like one.
Yeah. What is this on? Is this on your Nikon camera, your
No,
DSLR?
this is what I do use that with my D810, but
Yeah.
I'm talking about my 1600 Pro mono.
Yeah. I have found that the biases actually screw my pictures up a little bit when I calibrate them. I am unhappy with them, and I was experimenting around and said, well, let me try it without bias, and they turned out much better. So I've done that, and I did it. I tried it a couple times with a couple different sets of pictures, and the bias on my 1600 was just messing my pictures up.
When you say it messed it up, it added more noise, or what?
It added more noise. I think it took some of the pixels and threw them to 0, made them dark pixels. They weren't very good. And then I started reading around, and I read someplace that for a CMOS camera, if it's an astronomy camera like an ASI 1600, don't use bias. So I've never used bias ever since. On my DSLRs, I do. For some reason, I don't know why, it makes them better, but it screws up the ASI 1600 pictures.
Don't bias, at least with the DSLRs, doesn't it take out the noise especially from your shutter?
No, it takes out the noise that is injected when you read the image off your sensor.
So when you take the image and it comes up in like preview or something, that's where the noise comes from?
No, it's just when it reads it, right? You got your values sitting in your individual photo cells, right? Those are the values in there. They got to be read off somehow.
Mm-hmm.
So the number of photons that it saw, and the process, at least in the DSLR, the process of reading those values off injects noise into that. So it's a read error. It's a read noise.
Interesting. All right.
Now, why that doesn't occur on, or is less on the on our astronomy cameras, like the ASI 1600, I really don't know the answer to that question.
Maybe because these are largely cooled cameras and there's less noise because it's cooled.
Read noise is read noise. You would expect you would see the same on both, but and maybe it's just that the sensors that the DSLRs are using, they don't care about the bias being high. For normal pictures you take during the daytime, who cares about the bias noise? Your signal is so large that the noise won't really affect it all that much.
The other part you need to understand is that a dark frame with our astronomy cameras, our ASI 1600s and our 290 ASI 294s and everything else, is that when you take your dark frame, that read noise is already built in there, and there's no reason to have a separate bias frame if we are going to use a dark flat to calibrate our flats and a dark frame to calibrate our normal light frames. Then it's not necessary to have that extra step and have that extra bias. And I think that's where Doug was discovering that bias, when it was being subtracted out, it was actually being subtracted out twice. And that's why he was finding some of his pixels that were actually
that's what I was
zero.
thinking too. Maybe in the CMOS cameras, you're actually taking out the noise twice, once with the dark and once with the bias. Maybe that's the problem.
It's very possibly. And when I was more active on cloudy nights, I do recall seeing a discussion about whether to use bias at all in any camera, DSLR or otherwise. But it was a situation where this isn't acceptable to me. I need to have a better picture than what I'm getting. So I started experimenting around and took out the bias, and it came up much nicer.
I'll try that.
Any other questions?
No, appreciate you doing this.
Yeah. Will, did you get all your questions answered?
I think at this point I'll probably have some follow-up ones, in the future here, but I think we're good for tonight.
And we are recording this, so it will be on the MOS YouTube site at some point whenever Mark gets it processed and edited and put out there. So you can go back and see what I've done.
Excellent.